Hey guys, so this tutorial will cover the big push, which is your homework assignment over the weekend on page 71. So this assignment is a little challenging. It kind of gets at these ideas of acceleration and initial velocity that you studied on Friday with the substitute with Randy. And so I'm going to just walk you through the process of setting up a quadratic equation in order to figure out this time that it's going to take to get from the 9 o'clock position down to the water, the cart, which is 8 feet above the ground. Okay, so we know this relationship. We know that distance is equal to velocity times time. That's our most fundamental relationship that relates distance, velocity, or speed. We can use those for right now simultaneously. They're kind of mean the same thing. And time. This is that relationship. So what is distance in this case? Well, it's the total distance that the diver travels from the 9 o'clock position to the water level, which is what? Well, do we know the height to the center of the Ferris wheel? We do. It is 65 feet. So I'm going to label that right here. And I believe that's also given in your book. It's 65 feet to the center of the Ferris wheel. Do we know the height above the ground of the cart? Well, we do. It's 8 feet, right? That's given to us right here in this assignment as well. So what's the total distance traveled from the 9 o'clock position to the very edge of the water, the top of the water? Well, it'd be 65 minus 8 feet, which is 57. And this is a number that we've seen before, right? So 57 is going to go in place of D over here. We have our D. Perfect. Now we just need to figure out how to write our velocity. So do we know the initial velocity? We do. This problem tells us that the diver is going to be leaving the Ferris wheel with an initial velocity of 7.85 feet per second. That's in the second to last paragraph, okay? So we know our VI is equal to 7.85 feet per second. Perfect. Now, how are we going to figure out the V final? In other words, the speed that he's going to be traveling that minute he hits the water. Well, that's not something we can really numerically figure out right now, but we can figure it out as an expression involving time. So we know that in order to find that final velocity, in order to calculate it, we're going to take this initial velocity of 7.85 feet per second and add another 32 feet per second for every second that he's been traveling. And the reason for that is because our acceleration due to gravity is 32 feet per second. Okay? So we know that's our acceleration. So to figure out final velocity, and I know this is a big step right here. This is kind of a challenging piece, but one that's very necessary. We take our initial velocity and we add what? We add 32 times however many seconds he's been traveling. So if it's 1 second, it'd be 7.85 plus 32. If it's 2 seconds, it'd be 7.85 plus 64, because that's 32 times 2. And 3 seconds and so on. So hopefully you guys get that general idea. So we have our initial velocity, 7.85. We have our final velocity at 7.85 plus 32 times t. Give me just a second, Josh. How do we calculate this v right here, this average velocity? Well, what we can do is we can take the average of these two, 7.85 feet per second and 7.85 plus 32t. How do we calculate an average? Well, you've been doing this for several years, right? We add the two up and we divide by the number that we have, which is 2 in this case. So let's do that. So v average is equal to 7.85 plus 7.85 plus 32t, all divided by, well, there's 2 of them, so divided by 2. So this is an algebraic statement that we can simplify. What is 7.85 plus 7.85? Those are like terms. That would be 14, be 15.70 plus 32t, all divided by 2. And you can take it one step further. I know it's kind of hard to see. Let me point you down this way. And simplify this to 15.70 divided by 2. That's 7.85 plus 16t, because 32t divided by 2 is 16t. So this right here, all that legwork, didn't get us to an answer. It got us to an expression for the average velocity. Okay. What we're going to do now is we are going to plug in or substitute that 7.85 plus 16t into this v up here, which is our v average. So what are we going to end up with? We're going to end up with 57, which was our distance traveled that we figured out, is equal to 7.85 plus 16t, all multiplied by t. Phew, we're almost done. Now, is there anything we can do with this? Is there any way we can simplify this? And hopefully this isn't getting too messy for people. I'm going to draw a line just to kind of segregate what I'm doing over here from what we did over here. So if we use the distributive property, if we distribute t to both of these terms, we get 57 is equal to, well, 7.85 times t is just 7.85 t plus 16t times t is 16t squared. Okay? So this right here is going to be what you use, the 57 plus, or is equal to 7.85t plus 16t squared. That final equation that we came up with is going to be what you use to figure out the time it's going to take. Okay? Good luck. You can do it. Okay, see you Monday.